All right, guys, we are looking at page 21 in your booklets, okay? And what I'm going to do with you now is just an introduction to the respiratory system. So what you need to know is the difference between breathing, cellular respiration, and gas exchange. Okay, so breathing is the physical act whereby you bring air into your lungs and expel air that's carbon dioxide rich, okay? So breathing, if you had to describe breathing, I don't think you'd have any trouble with this. I'll say this is, sorry, pen running out there. All right, I'll try green. This is, we'll say, the physical act. So as we go further into this this system, you're going to learn, you've got the diaphragm working and the intercostal muscles working. So it's the physical act of those guys combining together and working together, of bringing in, I'm going to short form it here, oxygen-rich air, O2-rich air, and expelling CO2 rich air. All right. Cellular respiration. This is, you've seen this formula before. You really need to memorize it if you haven't done so. So glucose, C6H12O6 plus 6 molecules of oxygen, okay, being converted into 6 CO2 and 6 H2O molecules, in addition to approximately 36 ATP molecules, okay? So cellular respiration is something that goes on in the cells. Don't get it confused with respiration. So if you're talking about respiration, in terms of biology, we're talking about cellular respiration. When we talk about the respiratory system, that's the system that brings the oxygen in, okay? So they are not the same thing. And this will all come together in a second. And then gas exchange, this is going to be something that I'm really going to emphasize in this unit, okay? You really need to know about gas exchange. Gas exchange is when we exchange, okay, one gas for another, exactly like what it sounds like, right? But it's when we exchange the gas that we need the most, which is oxygen, for our waste product of cellular respiration, which is carbon dioxide. Okay, but there are going to be some places in your body where you're going to do vice versa. You're going to give off carbon dioxide in exchange for oxygen. All right, so think about this. Your lungs, okay, are the organs that are going to be really, really rich in oxygen. So I'm going to put high O2 there. Okay, so you've got a really high concentration of oxygen in your lungs, okay? And particularly in these little bubbles, okay? Little air sacs called alveoli. And what happens with the alveoli, so these are the alveoli, so like little bubble sacs in your lungs. So this is a lung, okay? So we could say that's the lung, all right? And the lung is fed with lots of blood, right? And so what's going to happen is you've got these capillaries, all right, feeding your lungs, keeping your lungs nice and pink and alive. You've got the capillaries that are coming into contact with all the alveoli. Now, the alveoli are really, really rich in oxygen, okay? But the capillaries that are going into the lungs are going to be very poor in oxygen, all right? So what's going to happen is that the lungs are high in oxygen, and I'm just going to get one more color out here. The capillaries, oh, blue, perfect, okay? Because blood that's low in oxygen can often look blue, all right? Capillaries are going to be low in O2, all right? So they're low in O2 concentration. Okay, square brackets mean concentration. And so what's going to happen is your O2, okay, is going to go from your alveoli into your capillaries, okay? So O2 moves from alveoli to capillaries. I'm sorry that writing is a little bit messy. I'm still writing on a slant with the phone in front of me right now, okay? And so that's going to be gas exchange. We're exchanging oxygen, and oxygen is going into the capillaries. Now, these capillaries have traveled through your entire body, all right? And what they're going to be rich in is CO2. Okay, so the capillaries have a really high concentration of carbon dioxide. And so what they're going to do then is they're going to allow carbon dioxide to go into the alveoli. Okay, I hope that makes sense for you. So carbon dioxide, I'm not going to worry about this question right now. CO2 moves from the capillaries to the alveoli. All right, and that's an example of gas exchange. The other place you're going to have gas exchange is in the body cells. Okay, so if we have now, think about this, these oxygen-rich capillaries are now going to take that oxygen to any body cell. So leaving the lungs, let's say it's going to your right arm. Okay, your right arm needs oxygen constantly, and so if we have a cell in your right arm, okay, so this is a cell. It could be any cell you want to think about. We'll say it's in your right arm, and it's been doing some work. So it's going to have carbon dioxide levels that are high, okay? And so when the capillary comes by, and I'm going to really make this capillary look much bigger, okay? So this is a cell anywhere in your body. We're just saying your right arm. This capillary, because it's coming from the lungs, has a high O2 concentration. So we're not just going to have one oxygen molecule here. You're going to have lots and lots of them. And we're not just going to have one CO2 molecule here. You're going to have lots of them. But this is another case where I said we're going to exchange carbon dioxide for oxygen depending on our location. So we're going to have carbon dioxide being given to the capillary, because this is going to head back to the lungs, and the lungs are going to give off that carbon dioxide. And we're going to have oxygen going into the cell, because that cell really needs oxygen to keep going through cellular respiration. Okay, so this is gas exchange, this is gas exchange. All right, we've got gas exchange between the lungs and the capillaries, and then between the capillaries and the body cells. What we're exchanging is going to be different. Here we're going to have oxygen going into the capillaries. Here we're going to have carbon dioxide going into the capillaries. Okay, super important that you try to understand that. And then just to wrap this up, I just want to ask you, and I can't get your answers unfortunately, I want to make you think about, what do these three things have in common? So this is the introduction to the respiratory system. What do breathing, cellular respiration, and gas exchange have in common? So take a second and think about that. Okay, and the answer is oxygen. Okay, these guys are constantly working at getting oxygen. So in other words, the common thread here is you're physically bringing oxygen into your body. Okay, why are you doing that? Because at every moment of the day you need energy, and that energy is going to be used with oxygen. So you're going to oxidize glucose. Without oxygen, you're not getting anywhere with this molecule. Okay, so oxygen is required in order to change this into something that is usable energy. And so the other common thread here is, what do we need? We need to get that oxygen to every single cell that's going to undergo cellular respiration. All right, and how do we do that? Through gas exchange. All right, I hope that was a good introduction. What are some good characteristics of a good gas exchange system? You do need to know, you need to have a large surface area. Okay, so the answer to that is we're going to have alveoli. Okay, so we're going to increase our surface area with alveoli, and you need to keep that surface area moist. So we did come from the ocean. Life did derive from the ocean, our life. And so if you look at something that lives in the water, they don't have any trouble exchanging one gas for another. Okay, but you and I, we have to keep our surface moist, so we still maintain that salt water that we came from, and it's in our lungs. Okay, now we're not sapping wet with water, that would be pneumonia, but we do have very moist lungs. We have to keep our lungs moist because that's how we're going to go through this, okay? Exchanging oxygen and carbon dioxide. So keeping yourself hydrated, keeping your lungs moist is essential because oxygen dissolves into that moisture, to that water much more easily than it does into dry air. All right, and that's it.